Welcome to another edition of Smart Contract Example. Algorand Python SDKs provides for developers easy and convenient way of expressing smart contract codes in a more natural form. Recently, the protocol was upgraded with room to use both on-chain and local storage in tandem with the existing one way of creating contract in a stateless manner. This means that as a smart contract developer, you are able to do more than just merely creating and approving transactions. Algorand's stateful smart contract can be very powerful if you can leverage on the underlying and complementary technologies such as stateless smart contract, atomic transfer, logic signatures, delegated approval, and many more. There are great starter kits, articles, solutions, and tutorials on the developers portal to get you started. In this example, we will create a stateful smart contract using PyTeal. It will be a simple role-based application that recognizes 5 addresses as ambassadors. One of the interesting parts that other contracts will be able to identify these addresses as what we tag them with. For the purpose of this tutorial, 5 addresses have been pre-selected as ambassadors and they will be eligible to get bonus from the bonus reward pool at a specified time of 28 days interval, so long the contract can read from some predefined tickers. It is assumed that the creator of this contract has a custom asset included in his account before now which can be read from the state of his account. For the sake of time, I will not cover asset creation in this tutorial. You can check the developers portal or my personal blog for tutorials on how to create Algorand's standard asset. I will use asset with reference ID 10403144. Predefined addresses that opted in will receive 5,000 win reward every 28 days. To guard against manipulation, I have set a counter written locally to the storage of addresses that opt in. It will be incremented at every round of transfer. Only the creator can issue a transaction from this contract. Let's get started. Pay attention to every line of code. There is enough documentation to help you understand what the code does. And if you cannot understand, feel free to ask questions in the comment section. Specify the Pragma version. Import all modules from the PyTeal library. As an example, we will use the following addresses. Get asset balance of the originator using ID 10403144. Setting the global properties. Using a sequence, we explicitly define the owner of the contract. Write the 5 addresses to the storage globally. Specify the date when the reward should be approved. Amount of reward cannot exceed 5,000 win token. Amount of total supply is the asset balance of the creator of this contract. And reserve initially set to 0 asset. A sequence can take an enormous amount of arguments. All arguments except the last must not return any value. Return a success value, an unsigned integer teal type uint64. Get the owner. Parse the amount of total pool reward. Set this address as the authorized account. Update the reward pool in storage. Update the reserve with the result of subtracting total reward amount from the total asset supply. These sections performs a few operations while an account interact with the contract for the first time. Write the following tags locally to the calling address. Check if caller is registered globally, that is, if the caller is pre-registered, then register a few identification keys such as balance, opted_count, is_ambassador, and pay_count. If all of this does not available to the interacting account, the program terminates. This part is responsible for transferring reward to the ambassadors. Firstly, we assert that caller is an authorized ambassador. Check that amount to send is within the set limit. We deduct the amount from the total reward pool. Add it to the user's account. Thereafter, we increment the counter, and update the time of last payment. Here is a utility for claiming reward. To effect the transfer function, the following conditions are required such as: check that the claiming period is within approved date. If the opted account does have the pay_count property, that is, has been paid before now. This part is crucial to the program. It is a list of conditions that specify the order at which the program logic should run. Each set of condition must evaluate to an integer of teal type uint64. Compile and run this code in your editor. You may experience some errors while compiling. Try to fix them to see how much you understand what is happening here. Full code is available on GitHub via the link in the description. Contributions are welcome. To learn more, visit developer.algan.org. There are a couple of tutorials and solutions to get you started. Also, join the developers forum for pressing questions. Don't forget to like and subscribe for more tutorials in the future. Thank you for watching.